So this is Grey Kangaroo UKMT 2023. We start from number 11. So matchsticks can be used to write digits, and we can make positive integers exactly 6 matchsticks. 6, 2, 5, 5, 4, 5, 6, 3, 7, 6. So if it is one digit, then we can make 0 or 6 or 9, but 0 is not positive integer, so we have only 2. And 2 digit, 1 and 4, so 14 or 41 or 77. 3 digit, 111. Yep, that's it. So we can have 1, 2, 3, 4, 5, 6. No, I mean 111 is 1, 6. And number 12, square with side length 10 centimeters long and 10 centimeters away from 2 of the vertices of the square. So if we can make like this, the equilateral triangle, and inside like this. So we have 8 here. But this is when I consider only the consecutive vertices. So if we consider the like opposite side, for example this and this, then this can be the one because it's 10 centimeter, 10 centimeter. So for example, all of these 4 vertices are the vertices who are 10 centimeters away from 2 of the vertices of the square. So we have altogether 12. Number 13. PQ, PR are equal, and here is 40. So maybe here 70 and 70, like this. So and there then that same. So here let's say x, this also x. Then here 40 plus x, and here 70 minus x, and here y. So y plus 40 plus x, y plus 40 plus x plus 70 minus x becomes 180. So y becomes 70. And number 14. Tom, John, Lily have like this. Tom scored 46. Let's say A, B, C. 3A plus B plus 2C becomes 46. A plus 3B plus 2C becomes 34. Then Lily, 2A, 2B plus 2C. What is that? When we add them together, 4A, 4B, 4C, 70, 80. So when we divide by 2, we can find 40. And number 15. Diagram shows smaller rectangle made 3 squares. Each of area 25, so 5 and 5. It's a larger rectangle. 2 of the vertices, a smaller rectangle, lie on the midpoint. So this is midpoint of the shorter side of the larger rectangle. The other 2 vertices, smaller 2 side larger rectangle. What is the area of the larger rectangle? Okay, so 5, 5, 5. So let's say here A, B, C. A squared plus B squared becomes 25. A squared plus C squared becomes, this is 15, 225. So what we need to find is 2A times B plus C, the larger rectangle. So let's see. So A and B and C have any, it doesn't have any other no, maybe this is more difficult. Just now I figured it out. If we draw the line like this, then this is the half of the upper rectangle. You know, because it has base of here and height of here. So when it has base of here, which means half of the rectangle. So 25. So altogether this is 75. So 150. And number 16, sum of 2023 consecutive integer is 2023. Sum of the digits of the largest of these integers. Consecutive integer. So usually when this is the odd number, let me put at the center is x. Then this is x plus 1, x minus 1, x plus 2, x minus 2, blah, blah, blah. But altogether, it should be 2023. So 2022 other than x. So we have another 1011. So x plus 1011, x minus 1011. When we add them together, 2023. So this and this, when we add them, we don't have 1011 anymore. So now we have 2023 x becomes 2023. So x equals 1. So largest number is 1012. So when we add the digits, that is 4. And number 17. Some beavers and some kangaroos are standing in a circle. 3 beavers in total, no beavers standing next to another beaver. So total 3, exactly 3 kangaroos stand next to each other, next to another kangaroo. Number of kangaroos in the circle. So let's say beaver, beaver, beaver. They don't stand together. None of them. So exactly 3 kangaroos are standing next to another kangaroo. So let's say 3. And kangaroo, kangaroo. For example, then this is 5. If we can find other case, for example, 2 and 2, no, we cannot make it because this is 4. I think this is the only way we can find the 3 kangaroos next to each other. Number 18. Snow White organized a chess competition. So on Monday, they played 1, 2, 3, 4, 5, 6 games, and the last dwarf, Dopey, how many games? Okay, so let's say Grumpy played 1 game with Sneezy, and Sneezy has 1 more game with Sleepy, and Sleepy has 2 more games. Then he played with Bashful and Happy, let's say 3 and 4. And Bashful had 3 games, Happy, Dog, and Dopey, let's say. Then Happy need to have 3 games. Oh, I cannot make it like this. Let me do it like this. 6 games. Dog plays 6 games. Then Dopey should have 1 game with Dog, and 4, 3, 2, 1, 0. So now Happy has another 4 games, and it should contain Dopey. So 1, 2, 3, and Dopey. And now Bashful has 2 games, so 2 Sleepy and Dopey. So Dopey has 3 games. And number 19. Elizabeth Beta want to write integer 1 to 9 here. Product of integers in any 2 regions that have common edge not be more than 15. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if 9 is here, actually it cannot be. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So now 9 should have only one common edge here. So 9 must be any of here. And let's make 1 here just to make easy to go. And let's make 8 here also, just to isolate them. And now we have 2, 3, 4, 5, 6. So 2 and 3. Because in the case we can 2 we can use it twice. 3 we can use it twice because it's small numbers here. So 7 and 6, 4 and 5. Oh, yeah. Now we can make like this. So 1 should be in the center. 9 and 8 can change their position. 2 and 3 can change their position. But 7 and 6 should be next to 2. So it depends on the position of the 2. So wherever 2 is, 9 and 7 can change only their position, each other. So 2 and 4 and 5 also same, 2. So this is all together 16 times. And number 20, there were twice as many children as adults sitting around the table. Age of each person at the table is positive integer greater than 1. Sum of ages adult. So let's see if the number of the adult is just x, then children is 2x. Then let's say each person, sum of the ages of 156. The mean age of the children let's say the whole group. Okay. Let's say mean age of the children is MC and mean age of the adult BMA. Then mean age of the children was 80 times x plus MC times 2x over 3x times 0.8. I mean 80% less than 0.2, like this. So this one is 1/5, 15. So 15 MC becomes MA plus 2 MC. So 13 MC becomes MA. But MA is 156 over X. So and MC becomes, we don't know. So sum of the age, so now 156 becomes MA times X. No, I mean we can figure it out from here. So from here, 13MC, like MC becomes MA over 13. MA is 156 over X over 13. But actually we need only, this is 12. But because we have the twice of the number of children than adult, so we can multiply by 2 here, 2x and 24. So the sum of the age of the children could be 24. Number 21. Martin, number of people in the queue, multiple of 3. He had many people in front of him as behind him. So he is the median. So we can tell multiple of 3, but odd number, because he can be in the center. He sees 2 friends, both standing behind him in the queue, 19th place, and the other is 28th place. So Martin, so which means it should be larger than 28, and 19th here, 28th here. So let's say if it is 33, just to check, then the median cannot be, median is 17. So this can be the answer. But if, for example, if it can be 39, then 39, the median is 19. Okay, so it cannot be. So we cannot make a 27 because we need 28th. So 27 is 33, 39, we can have only 33. Some mice live in 3 neighboring houses. So like this, every mouse left its house and moved to taking shortest routes. The number in the diagram shows the number of mice in the house. So yesterday and today, how many mice use the path at the bottom of the diagram? So from here and here, it should be adding 10. So let's say A, B, C, D, E, F. So A plus B is 5. C plus F should be 4. C plus D equals 8. And E plus F should be 7. And A plus E should be 6. And B plus D should be 10. So like this. So now we want to know D plus E, like this. So let's see. A, B, C, D, E, F here. So we know all together is 20. A, B, C, D, E, F, 20. And C and F is 4. So C and F is 4. And A and E, okay. So A and E, B and D. So now we need to take it out. B and D, A plus B, 5. So 11. Number 23. So Bart wrote the number, sum of the digits, 7. 7, a total of 10 times. So want to write the number as the sum of number using only the digit 7. A7, total of 19 times. 777, 777, then 2, 9, 7, 1, and another 77. Let's say, is it too much? 9, 6, 8, 1, and 77. 6, 4, 9, 1, 77. 3, 2, 0, 2. So now if we can add here like one more 777 and 3 more 77, then we can make 2023. So we can make 6. And Jake wrote 6 consecutive numbers on 6 white pieces of paper. Top and bottom of 3 coins. 3 times. 6, 7, 8. Color them red. And the second toss, the sum of the numbers you saw was 23. On the third toss, the sum was 17. So because now we have consecutive numbers, let's say 5, 9, possibly 5, 4, 3, 2, 1, 0. But 6, so let's say 3, 4, 5, 10, 9, 11, 10, 11. Then he saw 23. Second toss, then he saw 23. So sum of the number, maybe including 6, 7, 8, then it may be the sum of 23. So let's say out of here, whether we can make 23. 23, the last digit is odd number, maybe 3 odd or 1 odd and 2 even. So 23, let's say 8 and 15, 6, 9. Is it? This is 23, let's say. Or 6, 7, and 10. And third toss, the sum was 17. So the next sum should be 17, 3 numbers. We cannot make 17 with 10. Let's say we can make 17, 9 and 8, 4, 5. Oh, sorry. Different color. Let's say 4, 5, and 8. Then we can make it. Then we can start from 4 until 9. Then I think we can make it. Then the numbers is 4, 5, and 9. So sum is 18. Number 25. Rugby team scored 24 points. 7th, 8th, 9th games. Then mean point per game was higher than 9 games. Then it was after their first 6 games. Okay. So we don't know what was the total score until their first 6 games. Let's just call it X. Then X plus 24 plus 17 plus 25 over 9. This is higher than first 6 games, x over 6. So what is the smallest number of points they could score? So let's 18. So 2x plus 66, 132, 3x. So x is smaller than 132. So plus 66 again, plus, we don't know what is the score at tens, over 10 over 10. This should be exceed 22. Then the t is larger than 220 and minus 198, which is 22. So it should be larger than 22, so it can be 23. But we want to check once more just to make sure, because we have the one of the inequality here to make the next one. So let's say if t is 22, 88, so x is 88, 220, so x is larger than 2, 3, 1, 132. So this doesn't make sense, because here we found x is smaller than 132, but now it says x is larger than 132. So there is no x numbers who satisfies both. So this cannot be. So let's try again 24. So 24, if we put 24, this is 90 plus t is 220. So t is larger than, x is 22, t is 22. So x plus 88, no, I'm doing 24. So 90 over 10, 220. So x is larger than 130. So this is larger than 130 and smaller than 132. So now we can find x can be 131, which means 131 is satisfy this situation. So the answer is 24. So when you have the inequality like these two, like multi-steps, and when you use at the edge only there, then it's better to check once more with your answers.